video to help you with assignment 5, which deals with similar triangles. Similar triangles are two triangles with the same shape, but not necessarily the same size. When we talked about congruent triangles were two triangles that had the same shape and the same size. So similar triangles, they have the same shape. So if I look at these two triangles right here, I'm looking at these two triangles, they look like they're both the same sort of shape, but one's most definitely a lot bigger than the other one. Those could be said to be similar triangles. When you're dealing with shapes, angles make the shape. So anytime, and it doesn't have to be triangles, it could be any polygon. When you're dealing with shapes, angles make the shape, the sides make the size. So the sides actually tell you how big or small the shape is. The symbol for similar is this right here. So if this triangle maybe was, we had some letters on it. Something like that maybe. If we wanted to say that these two triangles are similar, then we would just name the first triangle. So triangle NTH. And we're going to talk about this on another slide. Then you got to make sure when you name the second triangle, we use that similar symbol, but when we name the second triangle, we have to match up the angles that match with each other, the angles that correspond to each other. Remember in congruent polygons or congruent triangles, when we were dealing with congruent triangles, we said that it was two triangles that all pairs of corresponding angles were congruent and all pairs of corresponding sides were congruent. So when we were dealing with congruent triangles, the angles that matched up were congruent and the sides that matched up were congruent. With similar polygons, this is what we're dealing with now, all pairs of corresponding angles are still congruent. So the angles are still congruent to each other, but the sides, the corresponding sides, are proportional. And that's where the last assignment came in, assignment 4, where you had to set, or you were solving proportions. What we're going to do is we're going to use two triangles and set up a proportion and then solve for the missing sides in certain triangles. So with similar polygons, angles are congruent, sides are proportional. Easiest way to prove two triangles are similar is use the AA theorem. Remember when we were dealing with congruent triangles, we used theorems like side, 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 angle, side, angle, and angle, angle, side to prove that the triangles were congruent. There's other ways to prove triangles are similar other than AA, but this is the only one that we're really going to deal with. It's the one that gets used the most and it's the easiest. And all AA stands for is angles, so a pair of angles and another pair of angles. So if you can prove that a pair of angles in the two triangles are congruent, and then a second pair of angles in the two triangles are congruent, then the triangles have to be similar. So here, if I look at this, I got angle L, I know is congruent to angle E because of the way they're marked. Angle A is congruent to angle R because of the way that they're marked. So that tells us that these two triangles are similar to each other. That's enough information to tell that they're similar. When we go to name the two triangles, so when we go to name the two triangles and tell whoever's looking at it next that they are similar, we have to make sure that we match up the corresponding parts. I matched it up down here for you already. And again, this is called, instead of the congruent statement, it's a similarity statement. That's what we're writing here when we're naming the two triangles. We're gonna do it a different way up here. I'm gonna say triangle, and we'll do it ALB. Doesn't matter how you name the first triangle. What matters is that when we're saying it's similar to another triangle, is that we match them up. So if we look at A is congruent to R. So if A comes first in this triangle, R has to come first in that triangle. Then we got L next. Well, L matches up to E over here. So E has to come next. And then B has to match up to the other one, which is Z. So we can name it that way, and that also tells us that angle B and angle Z have to be congruent to each other. All right? The other thing that all of this tells us, we know all those pairs of angles are congruent, but it tells us the sides are proportional. So if we wanted to set up a proportion, we could pick a side over here. Maybe I pick side BL. Well, side BL, you can either look at the picture and figure it out, or you can look at the names. BL is right there, so it has to be the same as this one, which would be ZE or EZ. And let's change that. I don't want to put that there. It's not going to make any difference. There's different ways that you can set up these proportions, but just to try to make it as easy as possible, I want to match them up this way. So BL matches up to EZ, and then I could pick another side. Maybe I pick LA over here. Well, LA in this one, notice what it's between. It's between the single tick mark and a single tick, or a single arc, and the single arc with a tick mark on it. Well, that's going to be the same as this one over here, which is ER. And then we'd have a proportion, and you should remember from the last assignment, we could solve that proportion by cross multiplying. Of course, we're going to have some numbers in there and stuff. And there's all kinds of different proportions you could set up using that. But you got to make sure that you match up the triangles. And again, the key thing for all of this is the angle-angle theorem. To prove two triangles are similar, all you need are two pairs of angles in the two triangles that are congruent. A scale factor, remember back, this was in the notes last time, a scale factor, you just take two sides in the two triangles that match up and set up a ratio, and that'll be the scale factor for it. If your scale factor is less than 1, then you're reducing the shape. If it's larger than 1, then you're enlarging the shape, you're making it bigger. The other thing to remember here, hopefully you cross multiply, you could do that if you did assignment 4. You cross multiply to solve the proportions, and we're going to do a little bit of that here in a minute. The main thing is we're going to set up these proportions, and we're going to find different the scale factors. A lot of times with scale factors, you have to just know if you're getting bigger or you're getting smaller, if you're making a reduction or if you're making an enlargement, so that you know how to write the scale factor. If I don't tell you, then I don't care which way you write it, as long as you have the correct numbers in these two locations. And it doesn't really matter which one's where. Now I'm going to explain that more here in a second. If I'm looking at this, this is just an example. They tell us that triangle NAT is similar to triangle BLZ. Well, the first thing, if I look at these two triangles, first thing I'd probably do, I see that I have two angles here. I'd probably find this third angle, and I can do that by adding the two angles that I know. Gives us 143, and then subtracting that from 180. Borrow there, 7. Looks like 37 degrees, so that means that angle right there has to be 37 degrees. That doesn't help us with anything on the other triangle, but that is something that we know. Now, if we look at this and they tell us that they're similar, that means that N has to match up to B. Well, we look over here, N is 53 degrees. That means angle B has to be exactly the same because the angles have to be congruent. So angle B is 53 degrees. Angle A, the next one is a right angle, it's 90 degrees. So that means angle L over here has to be 90 degrees. Angle T we just found was 37. It matches up to angle Z. So angle Z has to be 37 degrees. So we know all those angles just from that because the corresponding angles have to be congruent. Now with the sides, what we can do is we can look at the scale factor. Scale factor, we just pick, so to find K, the scale factor, we just pick one of the sides that we know in this first triangle, and we're going to compare it with a fraction to the side it matches up to in the second triangle. Well, if I look at this, the 6 would match up to this side, which that doesn't help us because we don't have a number there. The 8 would match up to this side, that doesn't help us. The 10 would match up to the 5. So those are the two I'm going to use. So 10, because NT right here, the length of that segment, if I look at up here in the names, N and T should match up to B to Z, that segment, BZ, which is right there. So our scale factor would be 2 if we reduce it down to 1. Now, if you know that we're starting here and we're going to that shape, then the scale factor is not going to be 2 to 1 because we went from big and we got smaller. And if we have a scale factor of something bigger than 1, which 2 over 1 is bigger than 1, then that means we're getting bigger. So the other way that we could write the scale factor is we could flip that upside down and put 5 over 10, which is 1 to 2. So if we know that we're doing a reduction, then we'd want our scale factor to be 1 over 2. If we know that we're doing an enlargement, then our scale factor would be 2 to 1. A lot of times this doesn't really matter, but if you're on the problems that we're going to do, it's not really going to make a whole lot of difference which one of these. So if I asked you for the scale factor, I would accept this answer or I would accept that answer. And I probably would accept either one of these two also without reducing it. That's fine, even if you don't reduce it. So if it's a word problem and you know you're making an enlargement, then you're going to want a scale factor where the top number is bigger than the bottom number. If it's a reduction, then you want the top number to be smaller than the bottom number. So if we look at this next one, again, first thing I would do on this, find this missing angle right here. They tell us that these two triangles are similar to each other. 90 plus 58, that's 148. You subtract that from 180 to find that third angle. That's 32, so this angle right here would be 32 degrees. We could come over here, and you got to make sure that you match them up. Notice this one, it's not just matched up for you. You might have to do something to the second triangle. You might have to spin it around. You might have to flip it, whatever. But you got to make sure that you're matching them up. We can look at the names and see how they should match up. A, they don't give you the names, and you got to match them up according to the markings on the triangle. A should match up to F. So angle A is 58 degrees. Well, that means angle F over here should be 58 degrees. Angle B is a right angle in this triangle. Well, it should match up to angle K. So angle K over here should be a right angle. And then angle C should match up to angle H. So angle C was 32 degrees, that means angle H has to be 32 degrees. So all the angles have to be congruent to each other. Now, what I didn't talk about on the other one with the sides, I'm going to go back to the previous one just for a second. We set up this ratio of 10 to 5 or 5 to 10, whichever one we decide to use here. If you're just looking at this, and I don't have any problem with you figuring it out, using your brain a little bit, you still have to be able to do it out because not everything's going to come out all nice and even like this one's going to. But we could also find the missing sides in this triangle. If we know that the scale factor, if we're going this direction, would be a reduction, so we're reducing it. That means the scale factor is 1/2. That means that this shape, all the lengths in that shape are half the size of this one. Well, you could probably figure out if this side over here is 6, the side that it's going to match up to in the other triangle then would have to be 3. And if this side is 8, the side that it's going to match up to, if I look at segment AT here, AT matches up to LZ. So if it's 8 over here, it's got to be 4 in that triangle because it's half the size. Now that's just using your head to do it. We're going to learn how to do it mathematically. So on this one, first thing, if I wanted to look for a scale factor, if I wanted to match them up and just find our scale factor, just pick 2 sides that match up, that we know numbers for. So if I come over here and I'm looking at these and I'm trying to match them up, the only number I know over here is 8. Well, HK, that's those 2 letters, so it'd have to be BC over here. That's right here. So BC is going to match up to HK. That means our scale factor is going to be 16 over 8, and you could reduce that down. Or if you wrote it the other direction, it could be 8 over 16. It really makes no difference as long as you match up other stuff. Now what we're going to do is we're going to find these missing sides. So let's say I want to find the length of segment KF. The way I'm going to do that is I'm going to set up a proportion. You've got to make sure that you keep things in order when you set up these proportions, otherwise it messes up your answer. So if I go 16 compares to 8, so I matched up this compares to that, and I want to find segment KF first, let's say. Now I got to figure out what does it match up to in this other triangle. So what does it match up to in this triangle? So I look at this, KF is between the 58-degree angle and the 90-degree angle, so that would be the same as this one right here. I could also look at the names and see KF are the first 2 letters, so it'd have to be segment AB. However you're doing it, you just have to make sure you match them up correctly. So 16 compares to 8, the same as 12 compares to segment KF. Now when you match these up, you got to make sure, if I took from this triangle first, so I started over here and I went 16 to 8, then on the second ratio here, I have to make sure that I start on this side and I go 12 over KF. So they have to match up. The tops have to match up, the bottoms have to match up. So the top 2 here were both from the first triangle. The bottom ones were from the second triangle. And there's other ways you can match them up. You just got to be careful and make sure that you're matching them up correctly, otherwise your proportion comes out wrong. And what I could do here is I could solve cross multiply, and I could solve for KF. You might not want to write KF in there, you might want to put in a variable X, Y, Z, whatever. If I set up another proportion, if I was trying to find HF over there. So let's say I started with HF, I put it right here because that's what I want to find. Well, HF in this triangle matches up to 20 in this triangle, so HF over 20 equals, and then since I started this on this side over here, we got to continue starting over here, so our top number on this other one's got to be the 8, and we know it matches up to the 16. Now where the scale factor comes in at is if you wanted to reduce this down, 8 over 16 reduced to 1/2, then we could reduce this and we could have HF over 20 equals, instead of 8 over 16, we could reduce it to 1/2, and then that makes our cross multiplying easier. So if you wanted to reduce it down to the scale factor, you could, and then use that. All right, some other things here. When we're dealing with similar triangles, some things you got to watch out for, things that we've learned earlier this year, are things like parallel vertical angles, right angles, and separating triangles, so on, so on, so on. And these are just 3 examples to try to show you how to deal with some of this stuff. Again, this is something we'd go a lot deeper into if we were actually in school. On this first one, if you see this angle's 52, this angle's 52, you should realize that that means that these 2 segments are parallel to each other when we dealt with parallel lines, because those angles are corresponding angles. So that means that these 2 have to be parallel. The other thing you should be able to pick out here is that there's 2 triangles there. We have the little triangle on top, triangle A, B, E, and you have to be able to split these off so that you can match them up. Then we have the big triangle, which is triangle A, C, D. And we know that this angle is congruent to this angle because they're both 52 degrees from this information. Well, then the other thing that we know is up here at the top, they both share that angle A. So reflexive property, anything equals itself. So that angle has to be, angle A there has to be congruent to angle A in the other triangle. Well, that's enough to tell us that the 2 triangles are similar to each other. So if we want to match them up, again, we're going to match them up by naming the triangles. If I name the top triangle, I'll name it triangle ABE. We're writing this similarity statement. Triangle ABE is similar to, we just have to make sure we match up the second triangle. Well, the A in this triangle matches up to A in that triangle. The B in this triangle is going to match up to C in this triangle, and the E in this triangle, because the way it's marked here, is going to match up to D in that triangle. So those are 2 similar triangles, and then from that, again, we know things like segment AB has to match up to segment AC, or the length of segment AB matches up to the length of segment AC, so on, so on, so on. Next one, remember that these tell us that those 2 are parallel to each other. When we have parallel lines, so this line's parallel to this one, we could use this as our transversal. Using that as the transversal, we notice that we form a Z there, so that tells us that this angle has to be congruent to that angle. We could have used GJ as the transversal, so we could have used that as the transversal. and said the same thing about those two angles. But the other thing that I'm going to do is right here in the middle, we know that these are vertical angles, so they have to be congruent to each other. Well, we got a pair of angles and another pair of angles. So by angle, angle, these two triangles are similar, and we can name the two triangles. I name the top triangle, triangle GFH. Doesn't matter how you name the first triangle, what matters is that you match up the second triangle. Now, on this one, you got to be careful, because here, the G doesn't have any marking in it, so it has to match up to the J in the other triangle. F in the first triangle has to match up to K in the second triangle. And then the H in this triangle matches up to the H in the other triangle. So that's our similarity statement. On this next one, hopefully you can pick out that there's actually three triangles in this picture. And I'm going to separate off all three triangles. Let's separate off this one. That's triangle, we'll just write it up here like this, and that's triangle PML. And then we also have the triangle that's over here, and it's triangle, it's got a P up here, a M here, and an N over here. We know that this is a right angle here, so this has to be a right angle, so there's a right angle there, right angle there. Then we also have the big triangle, which mine doesn't look very good. That's supposed to be a right angle there, and that's P, L over here, N over there. We know that this angle is 58 degrees. I'm going to put it in there. So that angle's 58. Well, that angle's the same right here, so that's 58. And they tell us that this angle right here is 58. Well, right now we have enough to say that all three of these triangles are similar to each other, because they all have a 58-degree angle and they all have a right angle. So all three triangles are similar. I'm going to erase some of this so that I can write all this out. So if we name this triangle first, triangle PLM. Doesn't matter how you name the first one. We know it's similar, and we just got to match them up. Probably should have picked something. Well, what we should probably do is we should probably figure out what the other angles in each one is. All right? Or you really don't have to. But if we look at this, you got the 58 matches to the 58, the 90 matches to the 90. Well, then that means the P angle up here, which would have to be 32 degrees, should match up to that. So the N. So N has to come first. Then the L is next. That's the 58-degree angle. Well, in this triangle, the 58-degree angle is P. And then the M is the right angle. Well, the M is a right angle over there also. So that's the second triangle. And then we could say that both of those are similar to our third triangle down here. And we just got to make sure we match it up the same way. The one that doesn't have a number in it is N, so that's got to come first. Then the L was 58 degrees, so that's this one, so that's L again. And then the right angle was last in both of the first two triangles. Well, the right angle this time is P. So, sorry, that's sort of sloppy. But those are our three triangles, and all three of them are similar. Main thing here is to remember what happens when you have parallel lines and a transversal. You could have alternate interior angles. like we had there. Over here, we had corresponding angles, and also used a reflexive property. Here we had vertical angles, so they had to be congruent. You got to be able to pick out all that stuff so that you can say that these triangles are similar to each other. Right, there's two theorems here that I'm going to go over. The assignment really doesn't have anything to do with these two theorems, so I'm just going to go over them quickly. The similar polygon perimeter theorem, if you have two polygons and you know that they're similar, then you can take the shape or a side in the first shape and set up a ratio with the side in the second shape, and that's always going to equal the perimeter of the first shape with the perimeter of the second shape. So what that allows us to do, if we're looking at these two polygons that I have here, and again, I'm going to go through this quickly because it doesn't affect your assignment, but it's something that wouldn't hurt to know. If I can find the perimeter of this shape, then I can find the perimeter of this shape without actually finding the lengths of all the separate sides. And sometimes that makes everything a whole lot easier. So on this one, I can find the perimeter here because I know all these lengths. I can add them up. 8 plus 12 is 20. 20 plus 4 is 24. Plus 7 is 31. Then 31 plus 14 is 45. So the perimeter of this shape is 45. On this shape over here, I could set up proportions to find this side, to find this side, to find this side, to find this side, so on and so on, then add them all up. But if we could just do it as one thing, then it'd make it easier, and that's what this theorem does. So if I take shape in the first side, or side in the first shape, and I want to match it up to a side in the second shape. Well, the sides that I know that match up are the 8 and the 3. So I'm going to set up that ratio, 8 over 3. And then I want to match up the perimeter of the first shape, which I just found was 45, to the perimeter in the second shape, which I don't know. So we're just going to call it P. And then you can solve that proportion. And when you solve that proportion, 8 times P is 8P. 3 times 45, that's 135. And you can divide both sides by 8, and that's going to leave you with just whatever P equals. If you divide that out on your calculator, and that's going to tell you the perimeter of this shape. And all we had to do was solve one proportion instead of finding all these missing sides and add them all up. So that's one theorem. The next theorem, similar polygons area theorem. So instead of dealing with the perimeter, the distance around the outside, now we're dealing with the area of the shape, whatever it is. All this is, it says area of shape 1 compared to area of shape 2 equals side from shape 1 compared to side in shape 2, but then you have to square that. And down here, this is the exact same formula, except I've split it up to maybe make it a little easier to do on your calculators. So you square the top, square the bottom. So if I'm going to set up this proportion, I know the area in shape 1, they gave it to us. We could maybe find it, but they gave it to us as 120. We don't know the area in shape 2, so I'm just going to make that a variable, make it A. And then the sides that we have, we got a side in shape 1 is 10, side in shape 2 is 3. The thing you got to remember here is you got to square both of those. So the first part's just going to stay the same. The second part, 10 squared is 100. 3 squared is 9. And then all we're going to do is we're going to cross multiply. A times 100 is 100A. And then whatever 9 times 120 is, get your calculator out, you could do that. And then all you're going to do once you have that done is you're going to divide both sides by 100. These are going to cancel out, and that's going to leave you with the area for that second shape, for that green shape. Again, those two theorems have nothing to do with your assignment. It's just something that normally I would go over in class. So I wanted to give it to you to so you have some understanding of it. All right, next thing I'm going to do is we're going to do 3 problems off assignment 5, the assignment 5 worksheet. So we're going to do 3 problems. Hopefully this will help you to understand them. All right, the first one is problem number 4. On problems 1 through 8, it says decide if the triangles are similar by angle-angle theorem. If they are, write the similarity statement and find the scale factor. So there's 3 answers you got to give for each one of those 1 through 8. I'm going to do number 4 right here. You'll notice outside there, number 4, it's got a blank and it says yes or no. You're just going to circle one of those 2. Then it says triangle something is similar to triangle something else. You're going to write in the triangles, make sure you match them up. Then it's got the scale factor. You're going to give the scale factor in that 3rd line. So this is number 4. And I forgot some stuff in number 4. I forgot that that's supposed to be a right angle. That's a right angle. So I look at these. I have the right angles. They're congruent to each other, so that's a pair of angles. But we need another pair of angles. Well, we got 48 here and 42 here. If you don't have enough information, then you just circle no. And you don't have to do any of the rest of the problem. But this one, we do have more information, because if this is 42, we can find this angle. 90 plus 42. We add them up, we get 138 or 132. We subtract that from 180. We end up with 48. So this angle up here is 48 degrees. Well, now we have this angle and this angle that match up. So that's another pair of angles. So yes, these 2 are similar because we have angle, angle. And that also tells us that this angle right here has to be 42 degrees. We can write it in there. Next thing we're going to do is name the triangles. Doesn't matter how you name the first triangle or which one is the first triangle. I'm just going to use ABC as the first triangle. I look over here, A matches up to T in the second triangle. B is the right angle, it matches up to G. And then C matches up to V. Many different ways you could have named those, that's totally up to you. You just have to make sure that they match up. Next one, they want the scale factor. All I'm going to do to get the scale factor is match up 2 of the sides. Notice that this triangle would sort of have to be turned around. This triangle over here would have to be turned around to match up to that one. If I look over here, segment AB, it's got to match up to segment, if I even look at the names, I could do it. It's got to match up, AB is the first 2 letters, then it's got to match up to TG in the second triangle. So it's got to match up to TG. Well, to do our scale factor, we just take the length of AB and we're going to match it up to the length of TG, which is 5. Again, you could write that answer down. You could reduce it. That would reduce to 2 over 1. If you did it the other direction, if you started with this triangle and went this way, then you would have 5 over 10, which reduces to 1 over 2. I would accept any of those 4 answers. All right? we'll put down that the scale factor is 2 to 1. And notice when I write scale factor, usually I leave it as a fraction because you want to know that there's 2 parts in the first triangle for every 1 part in the second triangle. Because you could write 2 over 1 just as 2, but when you're dealing with scale factor, you'd like to know how they match up. I would not mark it wrong if you just wrote down 2. That would be fine also. So that's how you do 1 through 8. Next, if you look at problem 9, on problems 9 through 24, you're going to set up a proportion, solve that proportion to find the missing side, or find x in each problem. So in problem 9, we have a picture that looks something like this, and all you're going to do is match them up. First, make sure, I think they tell you that each pair is similar, but we make sure that each one are similar. We got a pair of angles here, pair of angles here, so that's angle, angle, so the 2 triangles are similar to each other. And now we're just going to match them up. When I match them up, I like to make sure that in the first ratio, I always put in 2 numbers so that I don't end up with a proportion that I can't solve. So when I'm looking at this, I see that the 12 is between this angle and this angle. Well, that's the same as the 3, so I'm going to just match up 12 matches up to 3. Sometimes I'll even draw in the arrows to make sure that I'm doing it right. Notice that I started over here with the 12, so in my second ratio, I have to start with the 20. 20 matches up to x. So now we have a proportion that we can solve, and there's different ways that you could write this proportion. You could have said 3 matches up to 12 and x matches up to 20, and there's different ways, but it should give you the same answer, so we should all get the same answer. I cross multiply here and I end up with 12x. Cross multiply here and I end up with 3 times 20, which is 60. Then I divide both sides by 12. Grab your calculator and divide that by 12. Divide 60 by 12, you should come up with 5. So that tells us that the length of that side right there in that triangle is 5. And that's all you're going to be doing on these, is solving for that missing side. You just have, and setting up the proportions, the main thing. That's probably the hardest part. All right, this is what problem 17 looks like on your assignment. We're going to do the same thing. We just check it to make sure. And I think I marked something wrong here. Yeah, this is just supposed to have, it's not supposed to have a tick mark on it. So this angle, same as that angle, so they're congruent, so that's a pair of angles. This angle, same as that angle, another pair of angles. That's enough to tell us that the 2 triangles are similar. Now we're just going to set up our proportion. And again, I like to make sure I match them up and pick out ones that have numbers in these first 2 here. So if I look at this, I'm going to have to sort of spin this triangle around to get it to match up so that this angle lays on top of this angle and this angle lays on top of this one. Well, that means that the 6 over here is going to match up to the 48, so I can do that first. Now, since I started with the 6 and I went to the 48, I got to go that same direction in this second ratio. So when I look at this, that means I'm going to use the 5, and the 5, if I flip this around, the 5 is going to match up to the x. It's supposed to be an x. Then we just cross multiply, you get 6 times x, 6x. Here you get 5 times 48. 5 times 48, we multiply that out. I have my calculator with me. That's 40, that's 24, so 240. And then to solve for x, all we're going to do is divide both sides by 6. You end up with x equals 240 divided by 6. 6 will go into, it won't go into 2, but it'll go into 24 4 times. That's 24. We subtract, we get 0. Bring down the next number at 0. 6 will go into 0 0 times. So we end up with x equals 40. Now always go back and make sure that your answer makes sense. So we're saying that the length of this side right here where x is 40. So if we look at it, the two sides in this triangle were 5 and 6. Two sides in this triangle, 40 and 48. That looks like it makes sense. So the answer to number 17 would be x equals 40. Hopefully that helps. If you have questions, make sure you get a hold of me.